Welcome back to the third video in the series of restoration for the Philips BX750A. And as you can see, the offensive transformer has been removed, and there's no doubt about it, the primary is actually open, so it was in fact blown. And here is the offensive object. I pulled it apart because I wanted to see if there's any chance that these coils could be repaired. But it's obvious that that's not going to be the case. So this has been removed. There's the EI section of the transformer. That little thing at the top, the binding block, is something I removed because I want to use that on the new transformer. And of course, when you do this, you got to make sure you take some good photos. And well, I went one step further and did a drawing of it. And now the challenge is to find a suitable transformer for this. Now, what I have found is that this guy probably was not the original transformer. In fact, I'm certain it was not the original transformer, for the simple reason that what is readable here is 7,000 ohm primary, 4.5 ohm secondary. Now, 4.5 ohm secondary does in fact correspond to the speaker impedance, but the primary, I think in this particular case, is a bit too high. This thing is a normal EL84 push-pull stage, or rather single-ended stage, with what should be 285 volts anode voltage. As we can see from the schematics, actually it gives us 265 volts anode voltage. And for that kind of anode voltage, plate voltage, and the bias they've got here, which is a 220 ohm resistor and a 470 nanofarad bypass capacitor. This is obviously to enhance the higher frequency, since this is the mid-range and high frequency speaker. For this sort of thing, what the data sheets tell you about the EL84 is that you should have about 5K, we'll call it 4.5 to 5.5K kilo ohm impedance. Now 7 kilo ohms, which is what this guy is telling us, is a little high. The other reason that I know this has been changed before is the way it was fixed on the panel there. If you recall, it was here, across here, and it was fixed with one screw in here and soldered to the bottom end here. Now, what this tells me is that this transformer was put in here after the original one was removed. And I think two things are possible. Either the original fit in these two holes over here, or it was, as per the drawing, which we see as part of the data sheet. I have two output transformers for a single-ended stage. Now, both of these came out of radios that used an EL84 system. So I'm quite confident that at least one of these will be suitable. Now, what I need to do is to make sure that I'm not overstressing the output tube. So I've got to check on the impedance of these guys. And I'll give you a quick demo of how to go about it. Let's do that. The way to start is I've set the signal generator to produce a 100 Hertz signal, and I've put it at, let's put it at the maximum amplitude of 7 volts. And I'm putting this onto the primary of that output transformer and putting it on. And what I'm going to do, I've got 7 volts coming in the primary. I want to see what I have on the secondary. So let's do that. 137 millivolts. So 7 volts in, 137 millivolts out. I've got this at 100 Hertz. Let's just change that. I'm not sure just how accurate this is, to what frequency this will read AC voltage, but let's just check that. Well, if we leave it at 1 kilohertz, Seems to be fine, 136 millivolts. Okay, so we've got two values here. Let's take it the next step. So what I've got here is V primary, 7 volts AC. V secondary is 0.137 volts AC. The ratio is V primary over V secondary equals 7 over 0.137. And that comes out at 51. Now 51 is equal to the voltage ratio and also the turns ratio. Now the way the transformer works is if you have a primary and a secondary, it reflects the impedance placed across the secondary in the square turns ratio, the square of the turns ratio to the primary. So if we have 4.5 ohms here, which is about right for the speaker, what we have there is 4.5 times 51 squared, which equals 11,748. That's ohms. So this thing is 11K. This is an 11K or 11.7K to 4.5 ohms. Now what I do know is I want about 5, and I've got 11,000. I've got 11. So I want about 5.2K, I think is actually what the actual spec sheet says, but say 5 kilo ohms, and I've got 11.7 kilo ohms. So this transformer is not going to work. So this one is a bust. Let's try the other one. Now this one here is slightly different in that there are actually 3 connections here. So there's basically the secondary has 2 windings. They're connected in series. And I'm going to measure the result from the 2 outside ones, and then we'll go and look and see what we've got. Now I'm doing exactly the same thing there, putting the 1 kilohertz at 7 volts and see what we've got. This one is 0.27. Now if I change this to that one, I get 0.176, and if I do the other two, which is the 2, if I do say 2 and 3, I get 0.094. So I've actually got 3 options here. I can connect, let me take this off, I can connect 1 and 2, 1 and 3, or 2 and 3. So we'll see what we've got across both of them, or for those 3 different readings. We'll see what it is that we actually get in terms of impedance. Let's redo the sums. So we've got V in 7 volts. Then we've got this first option, V out 1, 2, 3. Is 0.270, so V out, or V in rather, over V out equals 7 divided 0.27. Comes to 26. That's option 1. That is 1 to 3. If we do now 1 to 2, we have V out over V in equals 7 over 0.176, which equals 39.7, call it 40. And if we do the last one, 1, or rather 2 to 3, we have 0. So V out over V in is 7 over 0.094, which equals 74. Now if I square these, I have Z in, or Z primary, equals 74 squared times 4.5, which equals 25K. Definitely not good. Let's look at the next one. Z primary equals 40 squared times 4.5, which equals 7200. So 7.2K. That's more or less what we had there. That could do, but it's a little bit high. Let's look at the first one. So Z primary equals 26 squared times 4.5, which equals 3.042. So 3K. That's a bit low. So what this tells us is I can use either this one or this one. This one is a little bit on the low side. This one is a little bit on the high side. I'm more inclined, because this thing had a 7K transformer in there, I'm more inclined to use this tapping. So it looks like it's going to be tapping 1 and 2. That looks like the one I'm going to use. So there, just to recheck this, we're looking at this the first and the second tapping, giving us 0.176 with a 7 volt input. Now, what I have here, this transformer is much bigger than the one that I had before. Now what that means is that this thing can handle more power. If it was smaller, it would be a problem. It would saturate and create a problem. Because it's not small, it's actually bigger. It looks like I may have a better solution. Now what I'm going to do is, I know that these two are the ones that that's going to produce a 7K output. Now the speaker, usually these radios, I'm working at 4.5. Some of them go from lower to higher, and I'm not exactly sure what the impedance will be at working frequency. So what I'm going to do is I'm going to leave the option open of actually using 1 and 3. So I'm going to leave the option open of using a 3K as opposed to 7.2K. So it'll be that one, and then with that one, or that one and the third one. Definitely not the second and the third. Okay, so at the moment I'm going to be using 1 and 2. I'm going to wire it up. What I'm going to do is I'm going to place that binding block thingy that I took out of the first transformer, and I'm going to find a way of fixing this at the top here. And here we are. I haven't cleaned up any flux or anything yet, but it's done. So I wound it up, or wired it up, onto that original binding block at the top there, which I fixed to this transformer with that screw and nut. And the reason is I can then just follow the drawing that I've done, and it actually looks original and it's less prone to mistakes. So I've got this all set, and all I need to do, just about mounting the transformer on here, it was a little bit difficult because this is bigger than the original one. So what I had to do is I found a screw coming there, which it's from the underside. It ties a ground lug to the chassis. I replaced that screw with a longer screw, put a nut underneath, so that binding block, or rather that ground connection, stays the same. Then I put the transformer on there with another nut on top, and that's one of those self-gripping nuts. So that's pretty tight on there. And I put it across like this so that it doesn't come too far off the edge. In fact, it doesn't come off the edge at all. And it doesn't go close to that tube, and it also doesn't get too close to that resistor over there, the green one, which isn't being used, but it's got the other one on the underside. So I had to make sure that everything fits in a way that doesn't create any risk of shorts on here. The other thing is that I do have a slight problem. What I've done is I've connected the speaker to 1 and 2. One is ground. The middle one is the speaker connection for the mids and highs, which is the channel that is run by this transformer. And I'm ready to test it. I need to put in that EL84, and I'm going to do so here. Okay, had to do that off camera. It's a bit difficult. But what you find now is that EL84 is actually too close to the speaker wires. I may have to, well, I'll have to put the wires in from the sides, bend those connectors down, and probably put in some thermal insulation between or on top of that binding block, so that I don't have a problem with heating from that EL84. So what I've got now is I'm ready to test this. And I now have the opposite of what I had before. I have the speaker connected to this transformer output, driven by this tube on the right. The one on the left has no tube, so we can leave that. It's not going to cause a problem. And I now am ready to test this thing to see whether we get this channel working. Now, what I do expect is a rather more tinny sound, because this is the highs and mids. The other one was the bass frequencies. So I'm going to prepare this and get back to you. Now, I am still wary about any errors, so I'm going to start safe. Put that on. And I'm going to hit FM. I've got an FM antenna at the back. We know we're getting something from FM quite clearly, so here goes. 140 milliamps. Well, that seems okay. It's not shorted. So let's put the volume up. Still nothing, but it's still warming up. I think I'm going to actually give it another lamp. There we go, 210 volt. Yes! It's not tuned. Brilliant! And as expected, it's a lot tinnier because there's no bass now. This thing works. I love it. Okay, good. So that seems okay. I just need to fix up that heating problem there with the tube being too close to the speaker connectors. It will melt the wire. But that's a temporary wire, speaker connection anyway. I still have not decided if I'm going to use the 7K, which is what it's set now, or the 3.2. And the way I've set it up is I just need to disconnect one wire at the bottom there to the second winding, pass it on to the third. There's one more thing I need to check, and this has to do with phase. Now, let me explain what I mean by that. Now, we've got to look at the phase issue. And the reason for that is what we have here. If we look at the frequencies, we've got our bass sort of, it's basically doing this. Let's call this the frequency at which the bass is more prominent, where the bass starts dropping off. And this is the bass where the treble, the mids and trebles start taking over. So that's bass speaker here and the mids treble speaker here. So all frequencies below this, and I would imagine this to be, I don't know, call it 600 hertz. I have no idea what it is, right? Quite frankly, where the cutoff point is. But what happens is there's a point here where both frequencies or both speakers are putting a signal through. So if you have a frequency of, say, 500 hertz, say there. Now, if you go up here, what you find is that the bass speaker is sending out a frequency of 500 hertz, and the treble speaker is also sending out a frequency of 500 hertz, albeit slightly dampened because it's already on the cutoff part of the band pass. So there is a point, in fact, theoretically, this is never zero. So theoretically, the bass speaker will pick up or transmit play frequencies all the way to the top. That's theoretically. In fact, it doesn't. But there is quite a big chunk of the frequency band that actually plays on both speakers. Now, if I have my bass speaker doing this and my treble speaker for the same frequency doing that, that's 180 degrees out of phase. So when the bass speaker is pushing out, the treble speaker is pushing in. If you look at negative as in and positive sign, positive curve is out. And when it gets to zero, that gets to zero, then the bass is pulling air into the radio, if you want to look at it like that, and the treble is trying to push air out of the radio. So these signals are actually fighting each other. They will null each other out to a degree. So what you need to make sure is that if your windings, or rather that the way you've wound the two transformers, make them in phase. So when this one's going up, that one will also go up. When this one's coming down, that one's also going to come down. So we may have, depending on how we've wired this last transformer, we may have this reversed. And it's very simple, because what you have is a transformer that does that. There's the primary. There's the secondary. Now we have the secondary grounded of both transformers, okay? One part of the secondary is actually shorted to ground, and that's your ground reference for your speaker as well. And this, the way that you wire these two up will determine whether it's in phase or out of phase. So you can do it one of two ways. You can reverse these two, or you can reverse these two. It's actually easier to reverse these two, the secondary, because the primary is connected to the tube anode. And this one, if you remember correctly, is connected to B++, 285 volts. These guys, the way I've wired them, if you remember what I said, I left a possibility of actually making it a 3K transformer. So I have purposely connected the wires to the secondary points, those tappings that you saw on the transformer, very lightly. In other words, I haven't bent the wires. I just pushed them into the solder lug and soldered them so that I could take them out again. I can take them out. In other words, I could take, say, this one out and put it on the other winding, if you remember. But I can just as easily flip them around if the phase is reversed. And the way to do that is to put in, I've got to prepare these with dummy loads or with two speakers to make sure that both the mids and the bass have loads on them. So I'll be running this for the first time with both EL84s connected. And then I'll put a scope across the two speakers and feed in a sine wave and check one channel will be connected to the bass speaker, the other channel will be connected to the mid-range speaker, and I'll choose a frequency where both speakers are reacting or responding, and I could see that I can just change the frequency on the signal generator and make sure that they're actually in phase. And if they're not in phase, I flip those around. So that's what I'm going to do next, but I've got to do a bit of preparation and connect another speaker here so that I don't run this thing on, without a load. I might just put a dummy load in here for now, on both of them actually, makes it easier. And then connect the scope and see what happens. So that's next. And here we have it. We've got the signal generator coming to the pickup input. I have pickup selected. Volume is fairly low. I've got the one channel of the scope connected to across the speaker. I left the mids and high speaker in place so that I can at least hear something. I've got, as you can see, both EL84s are there. So there's our output, and they're in phase. I mean, they're slightly out of phase. They're not exactly on top of each other, but they're not in opposite phase. They're not fighting each other now. And if I change the tone, you see what happens is that one of them goes higher, the other one goes lower. That's precisely what we expect. Bit of a noisy pot there still. But yeah, it's working. I hit it, and that's really, it's just chance. You know, it could have been exactly the opposite, and it wasn't. So I guess a little bit of luck came in there. And we've got the audio stage completely working now. And yeah, I'm pleased. I'm really pleased. This guy is starting to come together. So that's that for now. I have not quite done all the resistors and capacitor checks and component checks, connection checks. In other words, the schematic that I usually paint as I go along with these things I've done is not completed, and that'll be the next stage. But for now, my biggest headache is seems to be solved. It's getting the both channels of the audio working, because that was really annoying me, and I was procrastinating, and I'm sure that if you've done this, you know what I mean. Anyway, good. Onwards. See you again soon with the next installment. And if you like this sort of thing, please subscribe. Bye for now.